All right, hi College Algebra Trig. So this is Unit 9. We're on day 2 and page 5 of the notes. So yesterday when we did an example, before we started this example, and I told you it was going to be 4x minus 3, and we went through the whole derivative format of how you do a derivative, which means the slope of a function. I told you before we started that this was automatically going to be 4x minus 3, and you're like, is there a shortcut? Yes, so today is going to be the shortcut. So for the original function, f of x, with its derivative this, do you see any pattern? And look at your homework from last night. There are tricks and shortcuts for the derivative. So we're going to be talking today what's called the power rule for derivatives. You take, well, let me talk about something for a sec. If you take a parabola, which is, let's just say x squared. So if this is the function, I can tell you the slope or the derivative for the tangent line, the derivative, and that's going to be noted f prime. So f with a slash or f like this. So if the original function is f of x, the one is like with a apostrophe, a slash, a tick mark, and that's going to be f of x. The derivative will always be 1 degree lower. So the derivative of x squared, now there may be front numbers and stuff, will be 2x. So what I'm looking at right now is the exponent from the function to the derivative always decreases by 1. Okay, so what the constants are in the front and all that sort of stuff will change depending on the function, but what happens is the degree of this, so if I start with a cubic, the first derivative is going to be something squared. We can do a second derivative too, and that would decrease it by 1 degree each time. All right, so the shortcut of this is, so you have the long definition, how it's derived from doing the slope formula between a function. The shortcut of it is you take a power, so it's called the power rule, which means we're going to do the exponent of it. We can deal with that. You multiply for each term in a function, you multiply the degree or the exponent times the coefficient. So you would do 2 times 2, and that would be the front number. And then you decrease the exponent by 1. So when I said that's what it's going to be, I automatically knew to do 2 times 2, which is 4, and then say x to the first. So it's going to be whatever I start with minus 1. So that's like the first. And on the minus 3 here, I took this exponent of 1, and I multiplied that, so I did 1 times 3, so I got 3, and I had to decrease my exponent, so this was technically 0, which I don't actually even need, so it's just 4x minus 3. So to go through this, the power rule, so if I have a function like this, I take whatever the exponent is and multiply the front number, so the coefficient. So it starts off, if that's your function, so if f of x is a, so x to the n, so a and n are numbers, you do n times a for your new coefficient, you have x, so this is going to be a number, and then you subtract the degree by 1. Okay, so this is how it looks formally. So to do it over here, if you had 4x to the 5th minus 3x squared, you would multiply the degree with the exponent with the coefficient, so that'd be 20, be x, and you decrease it by 1. But you have to do this with every single term, so multiply the 2 with the negative 3 and say minus 6 x, and I go from 2 to a 1. So if this is a function here, this is its derivative. Okay, so it's always, the function is always 1 degree less, every term is 1 degree less than what you start with. All right, so it gets a lot easier here. So if you do this, if you feel comfortable doing this, go ahead and try it and then check. So I do 3 times 6, which is 18. And then I decrease x by 1. So 18x squared is how it starts. Then I do 3 halves times 2. So I do this whole fraction times 2, which is 3x. And this goes down to 1. So you can either write a 1 or just leave it as x. Now the 4x is 1 times 4, which is 4. And x to the 0, which means there's nothing there. And when you have a constant like -8, that would be like x to the 0, so 0 times that. So it just, anytime you have a constant, the derivative goes away, or when you do the derivative, the constant goes away. Alright, so this is the derivative of the original function. So some alternative notations for meaning do the derivative are f prime of x, f of x, d over dx, dy over dx, and I don't remember the last one right now. Just leave it there. So if you see any one of these, it means the same thing. So the symbol d over dx is called a differentiation operator because it indicates the operation of differentiating or doing a derivative, which is a process of calculating a derivative. Alright, so this is what I just talked about. If c is a constant, so like a number 10, there's no x with it, and f is differentiable function, then if you do the derivative of a constant, if f of x equals a constant, the derivative of that will always be 0. So meaning if the function is 10, the derivative of that is 0, or you don't have anything. So that's what I was talking about. When you have -8 up here, when you do the derivative, there's nothing for that. Alright, so this next one. So if you see d over dx, it means do the derivative. So you're going to multiply those two, and you get 12x, and 1 exponent less is to the third. Alright, if you have two functions added or subtracted, so sum rule, added or subtracted, do each derivative separately. Okay, so this is just the same as what I did above. If you have this and you have it in parentheses, just do each one. Okay, so this would be 6x squared plus lovely arrows, 8x. Alright, so on page 6, here's another example of the derivative of a constant. D over dx of 6 is automatically 0. Alright, so before tomorrow, I would like you to try numbers 1 and number 2 and have those so we can just double check them before we go on. Talk to you soon. Bye.